Hello everyone, welcome to my session. In this session, we are discuss about some application to branches in engineering, that is Matlab application to engineering. In this session, we are discuss about some application to branches in engineering, that is Matlab application to engineering. And the next, here electronics, civil, mechanical, chemical and food engineering applications are going to be discussed here in this session. Some of the toolboxes needed are useful for such above applications called signal processing toolbox and control system toolbox and food engineering toolbox and civil engineering toolboxes and mechanical engineering toolboxes are we are going to discuss here in this course objective 3. This is the first part, that is application to signals and systems. Remaining part we are going to analyze, that is applications in digital signal processing. It covers linear convolutions and Fourier transformation, discrete Fourier transformation and all, and then applications in control application in control area, that is a control system. Here we are going to discuss about stability in a feedback system, root locus of a feedback system and all we are going to discuss. Then application to chemical engineering. Here in this chemical engineering applications, mass transfer and chemical reaction system, these are all the things we are going to discuss. Then application in food engineering. Here some analysis based on Matlab, that is a 3D plotting of experimental data and the data for specific heat versus temperature and time. And also we are going to discuss about Fick's law. Here this Fick's law, every diffusion process is governed by Fick's law, so that we concentrate on Fick's law application to food engineering. To plot the drying process, one more example we are going to see, to plot the drying process of beet according to the Fick's law. Then finally there are applications in civil engineering. We are going to discuss about beam deflection, mass spring damper system and all. Then finally applications in mechanical engineering, damping system under harmonic movement at the base and plots of displacement and time versus velocity. These are the things we are going to discuss. Here the first one we start with application to signals and systems. In next part we are going to discuss about, next video we are going to discuss about applications in digital signal processing and applications in control, application to chemical engineering, applications in food engineering, and applications in civil engineering and applications in mechanical system. Here not only we are going to discuss with some topic, some interactive tools we are going to discuss. For example, in this video, in this session, application to signals and systems session, we are going to discuss about one interactive tool called signal analyzer app. Using the signal analyzer lab, you can visualize the signal and also we can analyze the signal, you can measure the signal, you can extract the signal. Just we are going to discuss about the hands-on session, purely this session hands-on basis, so that keep watching at the end of this session. The first topic is analysis of second order transfer function behavior. It's a second order and also third order transfer function behavior also we are going to discuss. All the engineering systems are modeled either by a differential equation or by a transfer function. For example, here we are going to see this analysis of second order transfer function behavior using Bode instruction, Matlab instruction. Here normally already all are very familiar with this Bode plots. The Bode plots are plots of magnitude in dB and phase in degrees of the transfer function n of s. Then second one is analysis of time domain response of second order function. Here also the unit impulse and unit step response of the second order transfer function can be obtained with some Matlab inbuilt instructions called impulse and step, which are the formats called step, numerator and denominator format. Based on that we are going to discuss about one simple example. Then Laplace transform and inverse Laplace transform. Matlab allows us to obtain the direct and inverse Laplace transformation of f of t with instruction called Laplace and I Laplace commands, Matlab instruction commands. Here one example we are going to see. Then next one, Fourier transform and inverse Fourier transform. In a similar way to the evaluation of Laplace transform, we can obtain the Fourier transform of a function as well as it's inverse Fourier transform. Here the Matlab instruction to get the Fourier and inverse Fourier transforms are Fourier and I Fourier Matlab commands. Then finally Z transform and inverse Z transform. The Matlab instruction to get the Z transform is Z trans, and for inverse Z transform I Z trans. This is a command we are going to discuss. Finally, introduction to Matlab signal analyzer app we are going to discuss at this final session. Okay, now we start with the whole course objective of this application, Matlab application to the engineering. Here first part in this video, first part we are going to discuss with application to signals and systems. Each and every point hereafter Wednesday and Saturday and Saturday every evening 6 to 7 Indian Standard Time we are going to meet this free course session. Okay, just please support us. If you are a new viewer in my channel, means kindly subscribe my channel. Please support us. Then next class onwards, we are going to analyze control engineering, food engineering, chemical engineering, civil engineering, mechanical, and also remaining engineering streams. Here these are answer approach we previously discussed in brief at the title session. Now what is the application to signals and systems? The engineering systems, all the engineering systems are modeled with the differential equation or transfer function. Here by using this we can obtain information about the stability of the system and its step or impulse response and its frequency response. Today topics related with signals and systems. Here second order transfer function and the time domain response of a second order function, and Laplace transform, inverse Laplace transform, Fourier transform and inverse Fourier transform, Z transform and inverse Z transform. Here just we start with one simple example for this analysis of transfer function behavior. Then this is let us consider the second order transfer function. This one, second order transfer function. Here Bode plots are plots of this magnitude in dB. Just in command line itself we can solve this, solve and analyze the transfer function behavior. Now we are going to discuss with Matlab command prompt. This is a second order transfer function. Here the natural frequency and damping coefficients are mentioned here. For this example, this is a transfer function, and we are going to apply natural frequency and damping coefficient as 2 and 0.1. Just to apply. Based on that, you will get this numerator and denominator block. Just we are going to find the frequency response of this transfer function behavior. We can update a plot of its magnitude and phase with the instruction called Bode instruction. Now, just you need to type the numerator and denominator. Numerator value is 4 here. Here s square plus 40s plus 4. Here the value is 1, 40 and 4. So that just you type the command, type the instruction, then equal to 1 in square bracket 1, 40 and 4. If it is in numerator value 10, here 2s square plus 10s plus 40 means here you need to put this value here. Now if you need to plot the Bode plot, that is your frequency versus phase and frequency versus magnitude. It's a Bode plot. You need to plot means this is a command to get this. This is the instruction Bode and numerator comma denominator. After that you will get this diagram. That is a Bode plots for second order function. Similarly, we can use for third order function. Here numerator value is 10. Here denominator value is 1, 2, 2, 1. So that we can, based on that, you give this instruction you can type and enter in command window. You will get this type of plot. Okay, here this is a third order transfer function. Just we are going to discuss about the transfer function is valuable tool that simplifies the study and analysis of linear time invariant system, LTA system. Now you start with this analysis of transfer function behavior. Just you type what is your numerator value is 4. Numerator value is 4, and this is our second order differential transfer function. We need to find out the values. We wish to know the response of ns with the value that is a natural frequency 2, and is a damping coefficient is 0.1. Okay, just you are going to see with this value, that is you type numerator in square bracket, you give the value 10 or 4, I think 4. Just in the meantime, you can see the workspace having this mat file, that is a numerator value 4, and what is the denominator value? Denominator value equal to 144. Then in the meantime, you can see the workspace, it is added, we added here. Then what is the command we are to plot the second order function? Here now just you see, after hitting this command instruction, you can apply good evening Sai Ram, and this here you can get this border diagram here for this example. Here we, by using this command line itself, command window itself, we can get this command using this simple instruction, that is a numerator and denominator, and this instruction, that is normal syntax for this one, to get this transfer function, to analyze the transfer function behavior, Bode numerator and denominator value. Denominator, you will get this output like this. Is a Bode diagram, there is a frequency versus phase and magnitude. Similarly, the third order function, here to obtain the third order function, we can analyze this function behavior. Just you need to type numerator value 10, numerator value. Just in meantime, you just to clear this workspace so that we can understand easily. And 10, and what is your denominator value? Denominator value is 1, 2, 2, 1, because it is a third order function. 1, 2, 2, 1. Don't forget to put semicolon here. Then what is the command here to get this plot? The output is showing here. In this manner, we can check this transfer function behavior by using this simple command called Bode command. That is a Bode instruction. Bode instruction, we can obtain a plot of its magnitude and phase with this instruction here. This instruction produces the plots of magnitude in dB and phase in degrees here. Next one is analysis of time domain response of a second order function. Here the unit impulse and the unit step response of the second order transfer function can be obtained with the instructions called impulse and step. Each of the format, there is a syntax for this one. Previously Bode versus numerator denominator, here step versus step in bracket numerator and denominator. Here for the second order transfer function, n of s, that is a 16 divided by s square plus 2s plus 16. Here these are the instruction type in, either type in Matlab script or we can type in command window itself. If to find this find the time response, Matlab can be used to find the impulse response of a system by using the command called this impulse. And you can also find the step response of the system using the command, it's called a step. Previous one impulse and step. impulse is used to find the time response, and step command is used to find the step response. This is a second order transfer function equation. Just you type this one. Numerator value is 16. Just in command you type itself, numerator value 16 and denominator values 1 to 16, and also you type this to find out the time response, time domain response of a second order system. You type this instruction impulse, in square bracket you type numerator and denominator. Just you type the command to get the figure, and type the step instruction to find out the step response of the system. Finally, by using the legend impulse response and step response, you will get the output here. Now we are going to do with this one. Now I am already type this Matlab script. Here is a numerator value 16, the denominator value is 1 to 16. Here you need to get the two response, one is step response, another one is impulse response. Here itself you can type with this one numerator value and denominator value and impulse. Also one more method, here itself you can type as a script, Matlab script, and save it as .m format. Just you need to click run. Now now we are getting two outputs. First one is impulse response and second one is step response. In the step response, it shows the legend value. There is a time versus amplitude we can get. Based on that, you need to analyze the time domain response. You use the instructions called impulse and step function. Here impulse function is impulse command is used to find out the impulse response of a system, and this step step instruction is used to find the step response of the system. Here any second order, third order system, you can find out and analyze the time domain response. Next one is the Laplace transform and inverse Laplace transform. Here the Laplace transform, Matlab allows to obtain the direct and inverse Laplace transform of f of t with the instruction called Laplace and I Laplace respectively. Here the functions called f1 of t equal to t cube e power minus 3t, and second function, that is f2 of t cos h of 2t e power minus 4t. These are the two functions to find out the Laplace transform and also inverse Laplace transform. Here the instruction Laplace is used to find out the Laplace transformation and also to get to obtain the result. Then for the inverse Laplace transforms, you need to type the instruction called I Laplace. I Laplace means inverse Laplace. So that this is the first one. They were first function, and this is the second function. Here you need to type the symbolic variables definitions. You have to initialize this one sims. This is a instruction is called sims taw. These are the symbolic variation definitions for to obtain this Laplace transform. Just you type f1. Here you see the first function f1 equal to t power 3. This is t cube. Here means t power 3 into, that is a star symbol, into exponential of minus 3 into t. Here every time you multiply with this star symbol 3t. Then after giving this f1 value, you need to give f2 value, that is f2. Here cos h, directly we are going to put the square bracket e power t. Here I missed this one, e power minus 4t. Just you type this one, e power minus 4 into t, the same thing you can get. Then f1 equal to Laplace of f1. You need to find out the Laplace value, so that you analyze, you initialize another variable called f1, capital F1. This is a Laplace of f1, and there is a Laplace transformation of f2 here. Then you are getting this obtained value here, f1 value and f2 value. You are getting this is Laplace transform of these functions. The same way you can get to find out the inverse Laplace transform by using the variable g1. Here just you type I Laplace of your function value, f1 value. Then g2 is a inverse Laplace transformation of your function 2, that is a f2 value. The same thing, we assign the variable for inverse Laplace transform g2 equal to I Laplace of this f2. Finally, we will get this output like this, g1 and g2. Just let us see this output is coming or not. The same manner I will give this one. Plus transform, just you need to type here. Here what are the sims? TAW. Then next one, f1 value, f1 equal to t power t cube into exponential of minus 3t, just my power minus 3t, minus 3 into t. And then f2 equal to cos h of 2 into t, 2 into t exponential of minus 4t, exponential of minus 4t. That's now we are given f1 function, f1 value and f2 value. Sir, almost we missed this section. It shows this here. Then next one, here previously here itself you need to give the multiply symbol. We are omitting this one so that it shows invalid expression. Check the missing multiplication operator. Here also it gives the correct value. Dd means here means you have to put this one again. Just you type. Then you need to compute this result, that is f1 of Laplace of function, f1 equal to Laplace of f1. Now we are getting this value for f1 value 6 divided by s plus 3 power 4 value. Similarly, you need to find out the f2 value. You assign the variable as f2 Laplace of f2. Just you check this value, f plus 4, s plus 4, s power, because previously I omit this e power minus 4t, so that we are getting the values here. Similarly, to find out the inverse Laplace transform, you need to assign the variable called g1 equal to this is I Laplace of your capital F1, I Laplace of capital F1. Just you will get this output t cube into exponential of minus 3t, t cube into exponential of minus 3t. Similarly, you assign the value for variable as to find out the second function of this I Laplace of f2. I Laplace I Laplace of f2. Now we are getting this g2 value, x power t. Just you can see in this manner. These are all the application of this Dickinson system. You can find out analysis of this second order differential function and third order differential function. Also, you need to plot the Bode function. You need to find the impulse and the step response, and also this type of transformations. The three type of transformations called Laplace transform and also Fourier transform and Isar transforms. By using this simple command, by using this simple in Matlab inbuilt command, we can solve engineering applications problem, engineering applications solution also there. In future classes, we are going to analyze some assignment solutions for this particular area. For example, this application area in renewable power system and stochastic process is an important topic we are going to discuss in future. Then just to check with another Laplace and inverse Laplace transform. We are finished one. Then Fourier transform. Here the Fourier transform by using the similar way you can evaluate the Laplace transform. You can obtain this Fourier transform as a function as well as its inverse Fourier transform. The Matlab instruction to get the Fourier and inverse Fourier transforms are by using the instruction called Fourier and I Fourier. That's inverse. For to find out the inverse Fourier transformation, you need to type I Fourier function. Okay, just let us see with this one small example with this function called f of t equal to e power minus 3 of t. Why now the same thing you need to type in command window for this one. This is for both Fourier transformation and also this inverse Fourier transformation. Here the Matlab function Fourier can be used to find out the Fourier transform of a signal, that is x of t, while the function I Fourier can be used to find the inverse Fourier transform of x of omega, this one. Now let us see with this example. Just you start with the definition. That is a symbolic variable definition is called this sims t. Just you clear all. Here also clear the workspace. Here this one sims t, this one Fourier transformation. Here just you need to type sims t and this expression. There is a function absolute value, absolute of t, and finally you have to find the result, that is a Fourier of f. Now we need to find out the result. The value is 6 divided by w square plus 9. These are output is the same we are getting. Similarly, you need to find out I Fourier value, that is a inverse Fourier transform value. Just you need to type I Fourier of your function f function. There is now 3 divided by pi into x square plus 9. 3 divided by pi into x square plus 9. You are getting these are function of f of t e power minus 3 of absolute value of t here. Based on that, by using this simple command we are getting Fourier transform and inverse Fourier transform output here. The next one, after Fourier transformation, these are Z transform. This Z transformation, the same thing. Z transform and inverse Z transform. The Matlab instruction to get the Z transform and inverse Z transforms by using the commands or instruction is Z trans and I Z trans. There is a inverse Z trans command. Now the same thing as an example, let us consider the sequence of x of n equal to e power minus kn. Okay, here this we are defining the symbolic variations definition sims k and n. Now we were give the instruction value, that is small x exponential of minus k into n. Okay, now we have to find the command. What is the command to get this? What is the command? This is a Z trans command. Find the Z transform of a discrete time signal using the Matlab command called Z trans. So that is a Z value, x value. You after hitting this instruction, you will get this output like this. That is a capital X value. This is Z divided by Z minus exponential of minus k. Okay, then for another example for to find out inverse Z transform by using this one. because z variable is here, so variable definition sims z, because this is a toolbox called a symbolic toolbox is used to find out the z transform, so that sims represent and z variables to find out the z variables. And what is a function, e power, that is exponential of 1 divided by z, and it is a command to determine the inverse z transform using Matlab command called iz trans. Then this x of, after this one we are getting the output value like 1 divided by n factorial. Let us see with this one. Okay, then let us clear all the things and clear the workspace. Then this is the z transform, the values sims kn value, that's sims kn, that kn values are represented here. Then these are function to find out the z transform. Then this is the instruction to find out the z transform. Now what is our output is yes, z divided by z minus exponential of minus k. Now see the output z divided by z minus exponential of minus k. In this manner you can analyze this one. Similarly for iz transformation, for another example called this one, the x is set of e power 1 by z. You know, see this one, sims z, there is a variable definition here. And the next, what is a function? By using this simple way we can get this any type of transformation, any type of signals and systems application you can find. That is the answer is 1 divided by factorial n factorial. Here is almost equivalent to 1 divided by n factorial. Here it represented 1 divided by factorial of n. In this manner we can analyze the outputs. There is a in this session we discuss with 4 or 5 analysis application to signals and system. First one is analysis of second order and third order transfer function behavior using these Bode plots. In the Bode plots we can find out the response of n of s with some natural frequency and damping coefficients value. The transfer function has application in control and analog filtering areas, so that it is useful to find out and plot the Bode plots in fraction of seconds by using this simple command called Bode command, Bode numerator and denominator command. And the next one, the same thing for third order function. And the second example shows the analysis of time domain response. In the time domain response, the unit impulse and the unit step response of second order system, second order transfer function can be obtained with the with two instructions called impulse instruction and step instruction. It has a syntax called step of numerator and denominator. By using this you can find out the second order transfer function with some more example. The next one, the Laplace transform. By using this Laplace transform, the simple command called simple instruction called Laplace and I Laplace. Laplace for to find out the Laplace transformation, and I Laplace command used for to find out the inverse Laplace transformation. Here we can, by using these two functions, just how to type, how to write the equation in command window using this particular equation. You can easily understand by using this approach, this adds-on approach. We can find out we can apply the equations and also get the output in fraction of second in command window. No need to type any program, script program and all. Just you need to type the corresponding instruction for particular transformations. Then next one, the Fourier transformation. Here the Fourier transformation, the two functions called two instructions, Fourier instruction and I Fourier. Here the Fourier function, Fourier transformation can be obtained with this command, Fourier command. Then the inverse Fourier transformation can be obtained with I Fourier instruction. Then finally this Z transform and the inverse Z transform. We were using this type of symbolic variable definitions. You can find out also Z transform and inverse Z transforms using these commands Z trans and I Z trans. Okay, next we are going to discuss about the interactive Matlab signal analyzer app. By using Matlab signal analyzer app, we can visualize the signal and also analyze the signal. We can also view the time response, time frequency response and spectrum, and also we can extract the signal, and also based on that we can generate a script also, which is an interesting one. Now we are let us move with Matlab signal analyzer app. How to get this app? Who are having 2016 Matlab version, it is available. Previous session not available this app. So who having above 2000 Matlab version onwards, we can use this signal analyzer app. Here one simple example. This is an introduction to Matlab signal analyzer app as a plot signals from command line itself. Here these are the command we are going to give to get this signal analyzer 3-channel random signal sampled for 1 second at 1 kHz. Now it is plotted with signal analyzer. Now let us see about what is signal analyzer, what are the things we are going to do with this signal analyzer. Just you go to help getting started or help command, just you type signal analyzer. So signal analyzer app, you can see this signal analyzer app used to visualize and compare multiple signals and spectra. Here by using this signal analyzer app is an interactive tool for visualizing, pre-processing, measuring, analyzing and comparing signals in the time domain and also frequency domain and in the time frequency domain. Both domain, there is a time frequency domains. Using the app, what are the things we are going to use? First, easily you can access all the signals in Matlab workspace. You can smooth the signal, filter the signal, resample the signal, detrend the signal, duplicate the signal, extract and rename signals without leaving the app. Okay, then next one, add and apply custom pre-processing functions. You can also apply, for example, you need to filter out low pass signal or high pass signal or band pass signal. You can also specify by using the Matlab functions. You can custom pre-processing also possible with this one. Okay, so next one, visualize and compare multiple waveform, spectrum, persistence, spectrogram and scaleogram representation of signals simultaneously with a fraction of second. We can get this one. Then how to get this signal analyzer app? Then the signal analyzer app, just you need to type this command signal analyzer. Just you type signal in capital A, analyzer capital A. These are some of the examples are given here. What are the extract voices from music signal, modulation, demodulation using complex envelope, and some important things, analyze signal with inherent time information, spectrogram view of dial tones signal, and the scaleogram of hyper chip, and extract region of interest from well song, and find and track ridges using reassigned spectrogram. Just we are going to see with one simple example. Just you extract. Before that, just you use this one. Plot the signals by using later you will see with one live script. Now we start with one simple application with to get the plot in a signal analyzer app. Just how to get this signal analyzer app, just you need to type signal analyzer, signal A capital analyzer. Now we have now we are getting this signal analyzer app. In this signal analyzer app, what all the things are there? In analyzer block, display block and time block. Time block, here you need to give the samples value, what is the units, what is the normalized y-axis, show markers, all things are there. In display section, display grid, here 4 sections are there. 4 sections are given. 4 sections are selected. In this manner we can set, for example, we need to analyze this 6 section. Just you click 6 section. Here normally this 4 is enough, so that I have chosen this 4 one. Okay, next one, what are the legend at top side or right side, and these are display option section. In display section, display option, and measure section, and zoom and pack section, and view section, and region of interest section, and time limit section, and share. Okay, and you can copy all the displays and also can generate the script. Okay, then is normally there's analyzer section. In this analyzer section, this is a file save and a new files create section. And next one, layout section. This is a signal tab, say bar, workspace browser, or display grid. Then next one, the signal table and pre-processing section, and the preparation option sections. Okay, now let us see with some simple example. Here in workspace itself there is no workspace because we clear all the things. Just you need to give some more commands for this one, some particular example. Here you choose this one, signal analyzer app. Okay, just you to plot the signals from command line. We can plot the call the signal analyzer app by calling the app in command line. Just you need to type signal analyzer. Then you need to create a 3-dimensional 3-channel random signal by using this one. The signal analyzer directly it goes with signal analyzer app. The 3-channel random signal sampled for 1 second at 1 kilohertz, 1 kilohertz sample rate. By applying this command in command window, just you see at workspace what will happen after hitting this instruction. Okay, now we are getting this one. This is a signal, filter signals are given here. In this filter signal, what are the signals? That's a 1, 2, 3 signals are there. Just you need to analyze the latter. Then next one, here we are created one 3-channel random signal sampled for 1 second at 1 kilohertz. And the next one, you need to because previously we have selected 4 section, so no need to go for display grids. This example shows, this PPT shows, go to use the display grid. We already you find out this where it is available. Here it is available in display grid. You go to display tab to open this empty display, select new display and click spectrum to analyze this spectrum of the signal. And also you need to create 2 channels sinusoidal signal sampled for 1 second at 100 Hz. Then the sinusoidal waves have frequencies of 5 Hz and 7 Hz. Plot the signal in the new display. How it is possible, just you get this one. By using hitting this instruction in command window, just you type. Okay, now we are getting these 2 signals. Here in this manner you can find out spectrum of the signal and also time frequency kilogram signal later we will get. Then next one, just where you are getting this one. These are the filter signals. Based on that we can get in the go to analyzer. For example, you need to analyze the smoothing the signal, means just you go to smooth, and also what are the methods for selecting this one, smoothing method, moving mean, moving median, Gaussian, linear regression method, and quadratic regression, robust linear regression, and also robust quadratic regression, and Savitzky-Golay regression. For example, we are going to use a linear regression option, means you can apply smoothing to signals selected in the table. Here I am choosing this one. Then what happen, you can check. After that the signals are shows here after smoothing this one. Here linear regression model you are choosing here, choose to here you can obtain, and analyzer, go to analyzer. Here you need to extract this signal, the low pass. Just you have to find out the, you have to give the pass band frequency and what is the steepness and stop band attenuation. You give there is a 10. After getting low pass, you are getting the low pass signal. You are extract the low pass signal here, so that in this manner you can understand. Also undo pre-processing also there, and your values, that is a duplicate selected signals you can get. This is a duplicate copy, duplicate signal. Based on that we can analyze by using one more important option, that is a view panner option. By using this view panner you can analyze the signal with this one. There is a time versus frequency signal. Based on that we are getting a time frequency. There is also you can get the scaleogram output, and snap to data and copy all the displays. You can generate also the script. Based on that you can analyze time domain analysis and also frequency analysis, and also both time frequency analysis also possible this with this one. Here this low pass block. Okay, here itself the legends values are shown here. Just here also some additional method for pre-processing. Here not only with the smooth, low pass, high pass and band pass, band stop, resample and detrend. Detrend means is apply detrend to signals in the selected table here, and envelope, you can also apply envelope to the signals in the selected table here. Based on that we will analyze one more thing is you can generate the Matlab script for this one. For example, this is for time versus frequency response. You can just generate this scaleogram script. Here this is a scaleogram plot. You can generate Matlab script for scaleogram. Just you can click here. You can compute scaleogram for our the example called this one. That is your 2 channel sinusoidal sample for 1 second at 100 Hz signal. In this manner we can set the parameters. You can also modify the parameter time limits, modify the frequency limits, and modify the voices per octave. All the things you can modify, and also you can click run means you will get this output. In this manner you can generate your Matlab script also. Then the final example called extract voices from music signal app. These are another application of this signal analyzer app. There is a digital equalizer example. By using this example you can extract using a digital music synthesizer, and also play a traditional song in a 3 voice arrangement. It's a interesting app. Just let us try with Matlab live script example. Just to close this one. How to get this example? Just you type this digital equalizer example for extracting the voice. This output is shows here. Then digital equalizer example. There is a live script file. Already know very well about live script. What is a live script file? Here live script file is a combination of your text equations and your images, and also after run in this right hand side you are getting the output here. Here also run section you can also possible. Here this is the example for extract voices from music signal. Here this example available in Matlab help menu. Just you need to type extract voices from music signal. This is the output. Here by using the implement a basic digital music synthesizer and use it to play a traditional song in a 3 voice arrangement. Just you can try with your own. If you are free hour, just you try this example as a open live script format is available here. Otherwise I will put the program in the description box. Kindly download it and just you enjoy this 3 voice arrangement by using this signal analyzer app. These are the program to implement a basic digital music synthesizer. Just if program sampling frequency and time variance and the LMH values and note values and song, and to hear the sound, just you need to type sound song fs, then tune the timetable and all the things you are getting here. Just you follow the steps, what is how to pre-process the duplicate signals using the selected filters, and how to get this high pass signal, then how to give the values, that is a passband frequency value and the steepness value and high pass value. These are the things we are going to apply here. Just you type signal analyzer app, then only we are getting the signal analyzer app. Then just if you discuss with this one, because previously not available here. Here you can see the workspace, and after entering this command we will get this values, that is for example fs value, t value, lmh value, song and tune. All the mat files are available in workspace browser. Here after hitting this one, we are getting the values of note and values of song, values of tune as a mat file. So just you need to run this section. It's in Matlab live script. It is also possible. Just you select run this section. After run this section, you are getting workspace. What are the variables available here? The workspace shows here. Then next one, just to open the signal analyzer. We already opened signal analyzer by using this command, signal analyzer command. We are getting this type of window. Okay, now let us follow the steps. What are the steps are given here? Open the signal analyzer block and drag the timetable from the workspace browser to the signal table. Click display grid to create a 2x2 grid displays. We already given 2x2 display cable. Otherwise, click on that display. Choose a display layout. Here chosen 4. Okay, so then the next one, the select the top 2 displays and the lower left and display, and click the spectrum button. Click the spectrum button here. Just say this is for spectrum and persistent spectrum. 2 types of spectrum are available here. The next one, click time and frequency. Then second one, time and frequency. Click here. It's a time and frequency section. In this manner, just you drag and drag the song to all 4 displays. Just you drag the song here. 1. Good evening, sir. Dr.M.Sivakumar, sir. Thanks for watching my videos. Thank you, sir. Then next one, just you tune. And what is your value? In this manner, you can analyze the signal. There is a signal analyzer app by using this one. Just you follow these steps. Then what is how to pre-process the duplicate signals from using signal filters. There is, you can also duplicate your signal by using this one. Here itself, you are going to find out the duplicate signal. By using this option, you can duplicate the signal. For example, this is a song, this is a tune song. Here in this block, to find out the spectrum, is that just I deleted here. Just I need to duplicate this one. Just in this one, in this manner, you are getting the duplicate copy of this one. Then in this manner, just you need to drag to the signal. Otherwise, you need to get this another block, means here itself. Sir, next one, just you drag. Based on that, each and every signal you can analyze by using this signal app. Also, this spanner, by using this spanner app, just you need to export the signal, also export to Matlab workspace and export as Matlab file, and also you can extract the signal by using this one. Between the time limit, you set the limits, time limits, extract the signal regions between time limits in a selected display. Okay, based on that you can select by using the what is the minimum value, what is the you need to give the samples minimum value and maximum time limits you need to give. In this manner you select how to give the band pass, how to extract the signal by using this analyzer app, band pass and band stop. It's a time frequency app. Based on that you can see, you can analyze any type of signals. Here tune songs, just to follow these steps we can get this one. After this one, just you can load this music, click run, you will get this output like this. In this manner, by using the signal analyzer app, to hear the different voices you type this command, then only you can get. There is a sound load flow, that is a FS pass 5 sound frequency. Then what is a spectrum, what is a you need to type this one. Okay, by using this interactive app you can extract voices from the music signal by using this interactive signal analyzer app. Okay, let us conclude this session. Next session, Wednesday, the same 6 to 7 in PM Indian Standard Time. We are going to analyze with applications in digital signal processing application areas with digital signal processing toolbox and also DSP Blockset. Please watch in my channel at on Wednesday 6 to 7 Indian Standard Time. Thanks for watching. Thank you.